Remember to keep your cameras turned on. Take a look. We started yesterday with these chemical formulas, writing chemical formulas, and as you can see, here we have the definition of a chemical formula. They are used as abbreviations. You can underline this in your book with your highlighter. They're used as abbreviations for compounds. And what does it show? It shows the symbols and the ratio of the atoms of the elements in a compound. Okay? I mean, when I was typing everything about this textbook, I try to include only the most important part. But I know that even though I included only the most important, it's still too much. Okay? And then I was giving you the example of NaCl. And I told you guys it is important that you recognize metals from non-metals, okay? In this example of NaCl, okay? In this example of NaCl, you have to take a look to the subscripts, okay? The subscripts are those numbers that appear partially below the line and to the right side of a symbol, okay? So what is a subscript? Are the numbers that appear partially below the line and to the right of a symbol. Do you notice any number there in the formula for NaCl?
No.
No, you don't see numbers. There is one reason for that. Take a look over here. The invisible one. Just like in math, wait. Yeah. Steven, you didn't change your name. Okay. Okay, so take a look where it says the invisible one. When we write chemical formulas, there is one subscript that is never shown. This is the case for number 1. So whenever you see a chemical formula, but you don't recognize a subscript, that means that the subscript is going to be 1. The only thing is that it is invisible. So if I ask you the number of atoms of sodium and chlorine in the compound NaCl, because you don't see the subscript, you will know that it is invisible, 1 for each. But because it is invisible, that means that we're not going to be able to catch it. We're not going to be able to notice it. So whenever you don't see a subscript, know that that it is the invisible one. In other words, this compound NaCl, Na, that is sodium, and Cl, that is chlorine, okay? This compound made of sodium and chlorine, you know that the number of atoms, okay? If I tell you the number of sodium atoms, you will say sodium, 1 atom. Because you don't see a subscript, you will know that there is the invisible one. And if I ask you chlorine, you will also answer there is 1 chlorine atom in that compound because same reason, invisible one. They're invisible, we don't see them. In this second example, this is the first example, that is NaCl. In the second example, It is an acid that is known as sulfuric acid. Okay, this one is known as sulfuric acid. Right now, in this moment, you are not going to learn how to name acids, but probably in a month you will know. Okay, now this acid, this sulfuric acid, is composed of how many elements? How many elements do you recognize in the example 2?
3.
3.
3 elements. You recognize hydrogen, you recognize sulfur, and you can recognize oxygen as well. Okay. So, this compound is made of 3 elements, and remember the definition of subscript. Subscripts are those numbers that appear partially below and to the right side of a symbol. To the right side of the symbol. That means that hydrogen is going to contain 2 atoms. Sulfur, I don't see the number of atoms. That means that is what number? If you don't see it,
1.
it is
1.
1, okay? And oxygen then is going to contain how many atoms?
4.
4.
4. So this is how you read a chemical formula, okay? You see the element and you see the subscript. The subscript indicates the number of elements that are in the compound, the number of atoms of the elements that are in a compound. So the H is hydrogen, the S is sulfur, okay? The O is oxygen, oxygen here. And what is in red tells you the number of atoms. For hydrogen, I'm going to have 2 atoms. For sulfur, because it is invisible, you already said, it's going to be 1 sulfur atom. And for oxygen, the 4 that you see, the subscript 4 indicates that we have 4 atoms of oxygen. So remember, the little numbers that are just below the elements and also to the right side of those elements are going to be the subscripts, okay? And represent the number of atoms. So how many hydrogen, how many sulfur, and how many oxygen atoms are we going to have in this example? Hydrogen, how many?
2.
2 atoms, okay? Sulfur
1
1.
1 atom.
is invisible, therefore it's going to be only 1 atom. Oxygen, how many atoms?
4.
4.
4 atoms, okay? Now let's see the example number 3. How many elements do you recognize in the third example?
3. 3.
Aha.
3.
We have calcium, we have nitrogen, and we have oxygen. So we can recognize 3 elements. Now, in this kind of examples, it is very important that you are very careful with, and here you need to be very careful with the parentheses. Some formulas that are more complex formulas are going to include parentheses. When parentheses are part of the formulas, That means that this group that is inside the parentheses, that is called NO3, okay? For this example, that is NO3. That group is called nitrate, okay? Just for you to know. It is there in one of the tables that I sent you, okay? This group of elements, those two elements bound together, NO3, they are called nitrate, okay? But because you can see this nitrate is inside parentheses and is after the parentheses is multiplied by 2, that means that you have two groups of nitrate in that compound. So that parenthesis, the number that is outside the parenthesis tells you how many groups of those elements are in that compound. In this case, the number that is outside the parenthesis is 2, so it's telling you that there are two groups of nitrate in this compound. So Ca stands for calcium, and because it doesn't have a subscript, you know that there is a invisible one over here. What is the subscript for nitrogen?
1.
Invisible one. The subscript for oxygen is?
3.
Okay. So here's the thing. To calculate the number of atoms, here is a little bit more complex. Calcium is not a big deal. It's outside the parentheses. So you're going to have just one calcium because it is invisible one. You're going to have one calcium atom. But take a look. For nitrogen, you're going to have one nitrogen inside the parentheses. And this one nitrogen is being multiplied by the 2 that is outside the parentheses. So in total, for nitrogen, you are going to have 1 times 2,
2.
2 atoms of nitrogen. And in the case of oxygen, you have 3 oxygens inside the parentheses that are multiplying by the 2 that is outside the parentheses. So in total, you will have 3 times 2,
6.
6 oxygen atoms. So whenever you see parentheses, you know that it's going to be multiplied by 2, but only those elements that are inside the parentheses. So these two that is outside the parentheses is just going to affect what you have inside. It's not going to affect calcium because calcium is not part of the parentheses. So it is like in distributive property in math. Remember what Mr. Calix told you about distributive property. If you have, for example, 3 multiplying x plus 2, how do you apply distributive property? Like this, right? You want to multiply the number outside the parentheses times everything that is inside the parentheses. It's going to happen the same here. So in total, here it's going to give you 3 times x plus 3 times 2, 3x plus 6. That's going to be the total for distributive property. It's almost the same that you have to apply here in chemistry. Okay? The number outside the parentheses is going to affect everything inside the parentheses, but just whatever you have in the parentheses. So calcium is not going to be affected by the 2 that is outside the parentheses. Then we have these characteristics for chemical formulas. What do they contain? They contain the symbols of all elements in a compound. So this chemical formula contains the 3 symbols that are making up the compound. This compound is called calcium nitrate. So this chemical formula is going to show all the symbols of the elements. When the formula contains one atom of an element, the symbol of that element represents that one atom. Okay? The number 1 is not used as a subscript, what I've been telling you. If you have only one atom, you're not going to write it. Okay? Why? Because it is invisible. Number 3. When the formula contains more than one atom of an element, the number of atoms is indicated by a subscript written to the right of the symbol of that atom. So, when you have more than one atom of an element, you're going to substitute it by a subscript written to the right side of the symbol. Okay? For example, in water, the 2 indicates that we have 2 atoms of hydrogen in the formula. So that's how you see it, okay? The number in the right belongs to the element before, okay? So that 2 affects hydrogen, but it's not going to affect oxygen. And then in the last one, we say, like we did in the third example, okay? When the formula contains more than one group of atoms, okay? Then parentheses are placed, okay? So when you have more than one group of atoms, then parentheses are placed around the group. So how is this parenthesis going to be affected? It's going to be affected by the subscript that is placed to the right side. So parentheses. Imagine, I'm gonna make one example here in the bottom. Okay. Okay, take a look at this chemical formula. This parenthesis is surrounded by the number 3 and by the number 2. The parenthesis is between 3 and 2, but the only number that is going to affect the parenthesis is the one that is placed to the right side. In other words, the 3 belongs to barium only, but this 2 from here is going to affect everything in the parenthesis. This 2 is going to multiply oxygen and also phosphorus, okay? But the 3 has nothing to do with the parenthesis. That's what it means. And the formulas, okay, the formulas show only the number and kind of each atom. They do not show the arrangement of the atoms, okay? It doesn't show you how the molecule looks like. No, it's just telling you how many atoms are in a compound. okay, how that compound is made of. So the formulas don't tell you about the arrangement, but just the composition. So they show only number and kind of atom. They do not show the arrangement of atom in a compound or how they are chemically bonded. And here the last part, what we have is a practice. We're going to work together, okay? What we don't finish, we're gonna do it. I'm gonna work in the exercises 1, 3, and 5, and you're gonna work in 2, 4, 6, okay? So 2, 4, 6 is going to be your practice. I'm gonna work with 1, 3, 5. They are the same kind of exercises. In the first part, it says, which of the following are diatomic molecules? Remember that yesterday I gave you mnemonics for diatomic molecules. Remember, have no fear of ice cold beer. Can you identify diatomic molecules in the first question?
Is O2.
Do we have another diatomic molecule here? Do we have more or just oxygen?
C.
Just B. Just B. Remember, the diatomic molecules are have no fear of iced cold beer. Okay, those are the diatomic molecules. They are single elements. Okay, and the only one from the first question, the only one that is diatomic from this group is the letter B. Okay, so these are the atomic molecules. You need to know them. I'm telling you, you need to know them. In the question 3, it says, what elements are present in each compound? So they're giving you compounds. The compounds are
It will be A.
Ki. Okay, so they're asking you what elements are present in each compound. The first compound, it says it is potassium iodine, which has the chemical formula Ki. How many elements are in this compound A?
2.
2.
2. Okay, potassium and iodine. Those are the two elements that are making up the compound potassium iodide. The second one, it says sodium carbonate. What elements are making up that compound?
Sodium and copper. No, cobalt, sorry.
Sodium, carbon, and oxygen. I have 3 elements, okay? Sodium, carbon, and oxygen. You can write the full name. The third one, it says aluminum oxide. How many elements are here? And what elements are those? How many elements?
3,
2 elements.
2.
They are 2 elements. Take a look. Aluminum. What is the symbol for aluminum? Al. Oxide, it refers to oxygen. So in total, I have only 2 elements. Aluminum and oxygen. Calcium bromide. How many elements are here?
2.
2.
What elements are those?
Calcium and bromine.
Calcium and bromine.
Calcium and bromine. You say calcium bromide, but the element is bromine. Okay? And then it says acetic acid. And they show you these elements. How many elements are there?
4.
There are 3 elements. Okay? Because hydrogen is repeated. In total, you have 3 different elements. What elements are those? Hydrogen.
Hydrogen, carbon, and oxygen.
Okay. So you can see that elements can be in different places in the same chemical formula. But in total, so what are the elements that are making up the compound acetic acid? Just hydrogen, carbon, and oxygen. In the last part, it says write a formula for each compound, and they are giving you the composition, okay? It says zinc oxide, it includes 1 atom of zinc and 1 atom of oxygen. What you're gonna do is you're gonna put them together, zinc and oxygen. And because they are giving you just 1 and 1 atoms of each, remember they are invisible, they don't need to be shown. In the second, it says potassium chloride, and they are giving you 1 atom of potassium, 1 of chlorine, and 3 of oxygen. So you're going to write potassium, chlorine, and oxygen. It says 1, 1, and 3, but the ones are invisible. So that is going to be the chemical formula for potassium chloride. For sodium hydroxide, it says that you need 1 atom of sodium, 1 oxygen, and 1 hydrogen. So it's going to be just Na, O, H, 1 of each, and the ones are invisible, so no need to write a subscript. And the last one says ethyl alcohol, 2 carbons, 6 hydrogens, and 1 oxygen. It's going to be written like that.